Today we transitioned from one-step inequalities into one- and two-step inequalities. And we looked at a couple of word problems, really more word phrases, just to start being able to take information that's in sentence form and translate it into a inequality statement. And so we looked at, let's look at number one. Caden can work no more than 15 hours. My general recommendation, just like we did in class, would be to start with my variable on the left and then determine which inequality symbol represents no more than 15 hours. So I know he can work 15 hours and he can work 14 hours. So everything less than and equal to 15 qualifies as an included value for this statement. So x is going to be less than or equal to 15. Let's see, number 5. Sam can take no less than 18 volunteers. And you'll see a statement like that often when you're trying to plan an event and you need to have a certain number of people in order to make it affordable for the event to take place. So no less than, x has got to be at least 18, but x can be greater than 18. So x is greater than or equal to 18. And once we get into word problems on Thursday and Friday, we'll start to take verbal statements like these and set them equal to a value and then solve for the variable x, just like we did with equality statements when we were doing expressions last week, expressions and equations last week. So this is really just a precursor starting to warm us up for what we'll be doing on Thursday and Friday. I want to look at just a couple of problems where we solve each inequality and then graph the solution. And number 8 is a prime example because I see a possibility for a couple of you to make a little slip up on final solution here. But the first thing I want to do is separate my minus 8 from my negative x. And I do that by its opposite operation, so I need to add 8 to both sides of this inequality. 7 and 8 is 15, is greater than negative x. And now we know that negative x is really negative 1x. And in order for me to get rid of that negative 1 that's being multiplied to x, I have to divide by negative 1. So I will also divide my 15 by negative 1 because what I do to one side of the inequality statement, I have to do to the other side of the inequality statement. So 15 divided by negative 1 is negative 15. We divided by a negative number here. So I need to remember to flip my sign. The negative 1 divided by negative 1 is positive 1. So I will have 1x, or we can call it just x. Now we are so close to being done, but remember we like to have our inequality statements with our variable listed on the left side of the equation. So once again, our second rule that allows us to flip the inequality symbol is when we are reversing the order of the inequality statement. So I will bring the x over here. I want to keep the open mouth of my inequality symbol facing the x, and my negative 15 will now take place on the right. And this inequality would read x is greater than negative 15. Now to graph. Personally, I like to have about 5 points on my graph just so it gives me a reference. I'll put the one I'm dealing with in the middle. And then since this is greater than, it's not greater than or equal to, it's just greater than. Negative 15 is not an included value. And we represent that with an open dot. And then I want to represent the line with every term on this line that is greater than, so that would be all of my positive values and anything between 15 and negative 15 and 0. So my line would be going to the right from negative 15. Now let's do one more example. Number 15 reads 3x over 5 minus 1 is less than 5. Unfortunately, we're in luck because our variable is already on the left side of the inequality symbol, so we won't have to move it around. So we simply need to solve this very much like we did our equations last week. I will add 1 to both sides. Negative 1 and positive 1 is 0, so that drops down 3x over 5 is less than 5 plus 1 is 6. And now I can multiply by my reciprocal, 5 over 3. So 5 times 3 is 15. 3 times 5 is 15. Those will both cancel each other out and drop down an x. And since I'm not multiplying or dividing by a negative term, my symbol will still stay the same. I'm going to simplify here just a little bit because 3 goes into 3 one time. 3 goes into 6 two times. So that will just help make my multiplication process much simpler to do in the head. 2 times 5 is 10. Over 1 times 1 is 1, which gives me just 10. So x is less than 10. And again, we can graph this. And then once again, we have a less than symbol. So my solution is going to have an open dot on 10. And all of my values to the left of 10, which are less than 10, will be included values. In other words, if I plug any of these values in for x, they will make this statement true. Like 7, if I plug 7 in for x, 7 is less than 10. Well, that's a true statement. This is an included value.